Good morning. Here I am going over the 2 free response questions from the packet. I'm sure you're really getting tired of this, but we're just beginning, people. Sorry about the sideways video. Clearly, I'm not probably going to find an answer to that. So here we go. We got this function f of x. It's this curve, bounded, blah, blah. Find the area of R. So to find the area of R, I'm going to basically just integrate the area of the curve. The integral of this curve minus the bottom curve. The bottom curve in this case is just 0. So the integral is going to be the integral of f of x. When I write my work, I'm just going to write f of x because it's a lot easier. Minus 0 with respect to x. And I have to go from this x value to this x value. So I have to go find that x value. So I'm going to grab my calculator. Sorry. Put it in the curve. Make sure that you're in radians. Oops, my goodness. Double check. Minus x squared over 3. Okay. Come on, dumb calculator, move. There we go. Negative 1.37, of course. So I borrowed a calculator. I'm not on float, I don't think. Nope, she's on float 3. So remember, you want to be on float so that you'll get all of the decimal places that are available for you. Oh my God. Oh. So negative 1.37312. So negative 1.37312, and I'm going from there to 0. So there's my work for part A. I'm just integrating from left to right. Let's see if you can see this here. So I'm going to go ahead and put that in the calculator. I'll put that in a second, and I'll post the actual. Nah, forget it, whatever. I'll just do it now. There's probably a fancy way to like save in the calculator what the function is so that I can only put in like a variable to represent it and only have to type it once. But I don't know how to do that. Okay, there we go. And 4.080. Part A. Part B, find the volume of the solid generated when R is rotated around the horizontal line y equals -2. Oh, joy. So I have to take this, only R, and I have to revolve it around the line y equals -2. So I have to revolve it around here. It's going to pop down here. And I'm going to have this kind of situation. So I'm going to have an outer and an inner. I'm going to have to subtract. It was around an horizontal axis, so my circles are going the way I'm kind of used to. So I have to add up from left to right. So I am going to be integrating from left to right, but I also am going to have to move everything. So this is what I was saying in the video, is that I would really rather not revolve around the horizontal line y equals -2. I want to revolve around the line y equals 0. I want to revolve around the x-axis. So I'm going to move everything up. So my new function is going to become all of this plus 2, because I'm moving everything from -2 up to 0. I'm adding 2 to everything. So when I set up my integration, I'm going to have the integral If this is just r, then I still need to go negative 1.37312 to 0. And I'm going to have pi r squared minus pi r squared, because I do have a whole with respect to x. The outer radius is going to be up to the curve, so this is going to be my f of x plus 2. And the inner part, which was basically 0, pardon me, is now 2. You can also just visually see that the radius of the inside circle is 2, 1, 2 away from the axis. And when I move it up, it'll still be 2 away. So that is the integral that I'm looking for. So find the volume. I'm putting this in the calculator. Again, you guys who had a question about the whole pi thing, if you're doing a Khan Academy and they're saying like keep it in terms of pi, then I'm going to leave the pi out basically. I'm going to basically be factoring the pi out to the front and out of these two terms. So I'm going to put the integral in. Negative 1.37312 to 0. Ah, see, I should have just cut and pasted. Oh well, whatever. Definitely need parentheses. So I got all that, but then I've got a plus 2. This is all squared. Minus 2 squared. All with respect to x. So I got 28.499, which if you were doing the Khan and you were confused, you would say 28.499 pi, although this would usually be more of a fraction or a whole number. But I'm going to go ahead and multiply mine by pi. So 89.532. Okay, part C. Write but do not evaluate an integral expression that can be used to find the area of S. So here we have S. It's just an area problem. We're not doing pi r squareds or anything else. So we're just integrating top curve minus bottom curve. But the problem is they never told me what the top curve was. So I'm going to have to go find the equation of that tangent line. So this is a tangent line to this curve at this point. So how do we find tangent lines? We need a point, we need a slope. So the point has an x value of 0 and a y value of 1, 2, 3. I think I should probably double check that. So we should probably double check that when I plug in 0 to the curve, I get 3. 0, 0, 0, 0, yes, I do get 3. To find the slope, what do? We take a derivative. So I take the derivative of f of x, and I'm going to plug in 0, and that's going to give me the slope of line L. So the derivative of f is going to be 3x squared over 4 minus 2x over 3 minus 1/2 minus 3 sine x. So I took the derivative of this curve, and now I'm going to plug in x equals 0. 0, 0, negative 1/2, 0. So the value of the derivative of the function at 0 is negative 1/2, so that's the slope of my tangent line. So I can use that to find the equation of this line. So the equation of this line is going to be y minus the y equals the slope times x minus the x. So y will equal negative 1/2 x plus 3. That is the equation of that tangent line. So if I want to find the area of S, I'm going to take the integral of the top curve, which is the tangent line I just found, minus the bottom curve, which is f of x, all with respect to x. And I want to go from left to right. So the left x is 0. The right x is, I don't know. I got to figure that out. So I have to figure out, where does the tangent line meet the curve? Where do those two things intersect? So now I could go and graph it. I think I already have in my graph, I already have f of x. So now I'm just going to take a second and graph the equation of the tangent line, negative 1/2 x plus 3. There it is. It looks just like what I have here, and I want to find that intersection point. Unfortunately, I have a lot of stuff all over the graph, but so I'm going to go from there to there. 3.389. So this is hard to read. 3.38987 is my intersection point. There we go. There's an integral expression to find the area of S. Calculus is a beautiful thing, people. All right, I'll do the next one in a minute.